Hi there! In this video we will talk about solving rational equations, specifically looking at proportions. What if I have one proportion set to another? So solving rational equations that are very simple in nature, okay? So we are learning how to solve proportions using cross products to find a value of a variable, and you'll be successful if you can recognize when an equation is a proportion, and you can identify cross products and cross multiply. So very simple, reduce the fraction to lowest terms, 10/15. Well, both of these, right, are products of 5. So we can go ahead and reduce, right, each of these. If we divide each of these by 5, we get 2, and divide 15 by 5, and we get 3. 10/15 is 2/3. Pretty simple, right? But keeping that idea of a proportion. Hey, hint, that's a proportion. A proportion is a mathematical statement that two ratios are equal. It has the form A over C is equal to B over D. So here is what a proportion looks like. And it's very important that your denominators are not 0. And again, here's another example of a proportion with equivalent fractions. So 12/18 is equal to 2 over 3. So these are the same, right? If I have 12 of something divided by 18 of another, that's the same thing if I have 2 divided over 3. They can reduce. Problems involving proportions involve at least one variable expression, such as 6 over x equals 12, 2 over x plus 3 equals 4 over 9, and x over 2x plus 3 equals 7/8. Kind of the idea here is we're going to see variables in the denominator. Since these are rational functions or rational equations, we have a variable in the denominator. So let's examine an important property of proportions. Given a proportion, A over C is equal to B over D, where the denominators are not equal to 0, we know that when solving an equation, we undo division using multiplication, right? So if I want to undo this C, I'm going to multiply by C. If I want to undo this D, I'm going to multiply by D. So in a proportion, both sides involve division. We can undo the division on both sides at the same time by multiplying both sides of the equation by C and D as shown below. So if I multiply both sides by the factors of the denominator by C times D on both sides, right? Because if I wanted to get rid of the C, right, aren't I going to multiply both sides? Multiply this side by C. So these cancel. Well, what you do to one side, you have to do the other. So I'm going to multiply by C over here. And same on the other side. I want to get rid of this D. So I'm going to multiply this side by D. Okay, they cancel, but I have to multiply by the other side, by D. Anyway, kind of what you get on this, some students, and I know you did this in junior high, is they call this the butterfly method. Let me erase these beautiful Christmassy colors. We go ahead, I'm going to multiply those two, right? The cross multiply. Okay, and I'm going to multiply these two, because that's what ends up happening, right? When I multiply by the C times D, the D is going to cancel, and I'm just multiplying B times C, right? So you get this butterfly method. Anyway, A times D, right? That's why they call it a cross product. A times D is equal to B times C. This helps us get rid of the denominator, and then we can solve some equations, which is what I'm talking about. This yields an interesting result. AD plus BC, no biblical references, just, good old math variables, are what are called cross products of the proportion, meaning they are products of the expression on the diagonals, and we can see it in the result above, that the cross products are equal for a given proportion. Note, this only works if you have proportions, okay? So if you have a whole bunch of other junk going on, all bets are off. You can't do this. For simple proportions, this means we can solve them two ways. We can undo division on both sides by using multiplication, or we can solve the proportion by doing cross multiplication. We must apply cross multiplication carefully. Be careful. And check for excluded values. These are values that will make the denominator 0. And we'll talk about this unit. So, what are the cross products of each proportion here? So this should be pretty easy. I'm going to go ahead and multiply 8 times 10. Well, that's going to give me 80. And I can multiply 5 times 16. Well, I know 5 times 6 is 30, and then 5 times 10 is 50, so 30 plus 50 is 80. 80 is the cross product. Okay, go ahead, take a second, pause, tell me what's the cross product of 4 6 is equal to 6/9. Well, hopefully you just picked one. Pick your favorite. I like 6 times 6. That's pretty easy. 36. That's the cross product of that one. 36 equals 36. Okay? All right. Let's go ahead and solve some equations. Solve each equation. Show the work that leads to your answer. So what I'm going to do here first is I'm going to go ahead, I'm going to solve this proportion. I'll do one each way, and then we can kind of find our best way. I have a rational equation, variable in the denominator. I need to get rid of the denominators. So I'm going to multiply. That's how we undo denominators. Denominators are just division. So undo it. I'm going to multiply by x on this side. I'll multiply by x on this side. And on the other side I have a 4. Get that 4 out of here. I'm going to multiply by 4. So I'm multiplying by 4x, okay, on both sides. And what happens is the x cancels over here, and we get 4 times 2. And on the right-hand side, our 4's cancel, and I get 9 times x. Okay, and there you go. Now we're on our way to solving this equation. Very straightforward. 4 times 2 is 8. 9x. I'm going to go ahead, I'm going to divide both sides by 9, and we get x is equal to 8/9. Bingo! There you go. Do we have to reduce or give a fraction or a decimal? No, they don't tell us decimal form. So anyway, that's multiplying by the product of the factors in the denominator. Let's check out another way. 8 over 3x is equal to -6. Well, whenever I have a whole number, what I like to do, especially when I'm dealing with fractions, is I like to make it a fraction. What? You like to make it a fraction? Yeah, makes it simpler and I don't do stupid mistakes. The denominator of this -6 is 1. Make sure you recognize that. There is a denominator, it's 1. And what I'm going to do in order to go ahead and do this is I'm going to just do a cross multiplication. So over here I get 8. And then I can do a cross multiplication, 3x times -6. Don't lose that -6 in there. And that gives me, oh my gosh, my brain is on freeze, -18x. Okay? So we'll go ahead and we'll solve for x. We'll divide both sides by -18. And what we get is x is equal to -8. Over 18. I like just bring the negative in the front. It's the same thing as keeping a negative in the denominator. And we can reduce this. Let's go ahead and reduce by what? 2? Reduce by 2. Does that help me? -4/9? Yes. That should be simplest form. Okay? Do I have to reduce? Yes. You're like 16, 17, 18. Okay? Your 12-year-old self would tell you to reduce. All right. Hey, go ahead, try this one. I won't harass you too much. Try this one, check your work. Okay, hopefully you got 35 over 6. Cross multiply, 7 times 5, 35. 2x times 3, 6x. Divide by the 6 to isolate your x, and you get 35 over 6. Did you get it? Good job, proud of you. Okay, round 2. Go ahead, that was 3. That was 3 dings, my bad. Round 2, oh, I'll cut this. I'll edit this. Round 2. Go ahead, try this one. Pause me. Check this one out. Okay, hopefully on this one you got 1/3. 2 times 1, and then 6 times x, you divide by 6. 2 6, 1/3. There you go. All you bakers out there are probably loving this. Okay, next example here. Is this the last example? It is. Oh my gosh, a binomial. It must be more complicated. No, just don't forget to distribute. Watch. Here's how this example is different. 4 over x minus 3 equals 2/7. I'm going to multiply. I'm going to cross multiply. This is the method that I like doing. So if you were multiplying by the factors, you can go ahead and do that. I'll definitely do that probably in the next lesson. But for proportions, I love just the butterfly method, taking that cross product. So I get 4 times 7. So here's how these questions are different. I just have 2 times x minus 3. You have to remember to distribute that 2 to that -3. That is usually what students make in terms of error. So 2x minus 6 is equal to 4 times 7, which is 28. And now I have a two-step equation, which I know you did in junior high. I'm going to use SADMEP, reverse order of operations, to isolate my x. I'm going to go ahead, I'm going to add 6 to both sides. 6 cancel there. We get 2x is equal to 34. We'll go ahead and divide by 2 on both sides. 2 cancels there. and we get x is equal to 17. There you go. Pretty easy. Here's a practice one like we always do. Okay, pause me. Please try this example. Don't forget to distribute. Check my work here. All right, hopefully you got negative 14. I went ahead and multiplied negative 9 with 4 and multiplied 3 times x plus 2. We went ahead and distributed this 3 to both the x and the 2, and then we solved. So subtract 6 on both sides gives you a negative 42. This might be a source of error if you said negative 30. Remember, they're both negatives, right? So you have 36 holes in sand, and you dig 6 more holes in the sand at the beach. That's a lot of holes. People are probably falling all over the place. Negative 42, and then we go ahead and divide that by 3, and you get x equals negative 14. Okay? Hopefully in this video you learned how to solve proportions. That was the goal of the video. If you learned something or learned that, give the video a thumbs up. I'll catch you in the next one. Take care, guys.